This video looks at how to use the height and the velocity rules that both depend on gravity. So they deal with things that are falling, that are free falling. So this height rule, our output here is the height of the object after some amount of time, after time t has gone by. So this is the height. It could be the height where something ends up, or if time is 5, if it's 5 seconds, it's the height off of the ground after 5 seconds. Okay. Our g is the acceleration value due to gravity. So gravity not only causes things to fall, but it causes things to accelerate. If we're dealing with units that are feet in seconds, then g will be equal to 32. If we're dealing with meters in seconds, then the g value will be 9.8. So far in classes, we've just looked at feet in seconds, so this value would be 32 here. Again, t is time in seconds. V naught here, this is the velocity at time 0, so it's the initial vertical velocity. It's really important to realize that since this is a height rule, since we're talking about a vertical motion, that this has to be a vertical velocity. Okay, be careful about that part. And this is the initial height. This is h naught, the height at time 0. Okay, so there's two h's here. This is the initial one. This is where it starts, and this is then where it ends up after some amount of time has gone by. Okay, so if I think about the hammer situation that we worked with in class, we looked at a situation where a hammer was thrown and it ended up falling on somebody's head who was 6 feet tall. So since it ended up at a height of 6 feet, that's our output. We have -1/2 times 32 t squared. The initial velocity, I can't actually remember that right now. We'll pretend it was 23 feet per second. So times 23 times t, plus the initial height, I think was about 20. Okay, and we can simplify this to be -16 t squared plus 23t plus 20. So this part is our rule, this 6 is the output. And if we were going to inverse this to find the time, we would have to put this in a vertex form, and there's another video showing you how to do that and reviewing some of the methods that we talked about in class. We also looked at a velocity rule. So again, gravity causes things to accelerate over time. So gravity has a part in this. This velocity rule, this is a vertical velocity over time. Again, g is going to be 32 if we're working with feet in seconds, or 9.8 if we're working with meters in seconds, and this is the initial vertical velocity that we saw before. So if we were looking at the same situation, something was initially thrown at 23 feet per second, then the velocity over time would be equal to -32 times t plus 23, and that would equal our velocity. If we plugged in a time value, we would know what that velocity was. Remember that velocity is directional, so if something's moving upwards, there will be a positive velocity. If it's moving down, it will have a negative velocity. Same thing with forward and backward motion, although this is vertical, so we're just looking at something moving up is positive, something moving down is negative.